Okay, in this video we're going to take a look at problem number 101, and again we're looking for displacement and we're looking for total distance traveled, given that we have the velocity curve or the velocity function over the time interval from 1 to 4. So again, for displacement, it's pretty straightforward. Displacement, that is just the integral, which gives us the net change in position for a velocity function of the velocity function, and we'll rewrite that as t to the negative 1/2 power dt, and we're looking at that from 1 to 4. Now this we could do algebraically, it's not a problem. So we're going to have t to the 1/2 divided by 1/2, or 2t to the 1/2 power from 1 through 4. And we're going to plug in 4 square root of 4 is 2. 2 times 2 is 4. Minus square root of 1 is 1 times 2. And so we should end up with a displacement of 2. So we put the function in the calculator, x to the negative 1/2 power, remembering to put the rational exponent in parentheses. And if we were to graph that, not much of a graph there. Well, I probably have my old window on. So let's see what we have. We want to go from 1 through 5 by ones, and then simply a negative 2 to positive 2. I would imagine that should be fine by ones. Let's see if we get something a little bit better. So from 1 to 4, we just have that area there. Oops. Bring the calculator back. We have second calc. We want option number 7. The lower limit is 1. The upper limit is 4. And so there you see we have 2. And that is in this case, it's going to be both the displacement and the total distance, because none of this was below the x-axis. So there was no turn to the left. It was motion to the right the entire time. Alright, so I put some of those graphs onto the screen there. We have the graph of the function showing that the velocity curve is always positive. On the interval, at least on the interval from t equals 1 to t equals 4. And so the area under the velocity curve between t equals 1 t equals 4 gives us our displacement, the net change in position. In this case, it's all positive. There's no negatives to zero out there. Okay, so we'll go on to problem number 103. And problem 103 is very similar. Well, it only asks us to find the total distance traveled by the particle. So the particle is moving along the x-axis. The position of the particle at time t is given by x of t is equal to t cubed minus 6t squared plus 9t minus 2 on the interval from 0 to 5. So since we're only looking for the total distance traveled here, we'll just put that into the calculator like so. And let's take a look on the interval from 0 to 5. I think my window is already set up for 0 to 5. And we'll see what happens here. You can see that on the interval from 0 to 5, that the velocity starts off being negative, which means that the particle is moving left. Here, then it crosses the x-axis and begins to move right. The velocity becomes positive up until just past 2 or around 2, and then it begins to move left again. And then following this, it goes back to moving right again. So on this particular time interval, there are 2 intervals at which the particle is moving to the left and 2 intervals on which the particle is moving to the right. And so in order to find the total distance traveled, we would have to use the absolute value of the velocity function. So you can see the velocity function there. What's going to happen when we take the absolute value is that it's going to take all the negative segments of the curve and flip them over the x-axis. So we'll go back to y equals, second, delete, gives us insert. We want to go to math, over to number, to option 1, absolute value, close the parenthesis at the end, and now when we go to graph, you'll see that everything bounces off of the x-axis there. Now we can't really see all the way up to 5, so we're going to need to increase the window on the y max. Let's say that goes up to 10, but it looks like it was growing pretty fast and we may not even catch all of that. Alright, so we don't see it all there, but we have a pretty good idea of how the function is growing over that interval. So we're simply going to take the integral here, and that would be from 0 through 5, and the area between the curve and the x-axis is going to give us the total distance traveled, converting all of the segments at which we're traveling to the left to positive distance values. And so we end up with 13.9.749. Okay, so I've put that a copy of that graph also on in the window there, and you can see what we've done is simply taken all of the segments that were below the x-axis and flipped them over the x-axis. In the second graph, we've also extended the y values so that they go a little bit higher than what was in the original graph function. But that's going to be the difference between displacement and total distance traveled. Displacement is simply the integral, and it's not asked for in this particular question, but it would just be the integral from 0 to 5, and the negative areas would cancel out with positive areas, and we would end up with a net change either to the left or to the right with respect to our starting position. When we're doing total distance traveled, we're treating everything, whether it's to the left or to the right, as distance traveled, and we're adding up the positive values or the absolute values of the distances traveled in either direction to get our total distance traveled, which in this case would be 13.749 units. Alright, so that's going to do it for this section of problems and for Chapter 4, Section 4.